Now let's see some properties of polar form. For that, consider complex numbers z1 is equal to mod z1 cos alpha plus iota sin alpha. This is, we know, polar form of complex number. Okay, and z2 is equal to mod z2 multiplied by cos beta plus iota sin beta. Now let's multiply these two complex numbers. Then we have z1 z2 is equal to mod z1 multiplied by mod z2 multiplied by cos alpha plus iota sin alpha multiplied by cos beta plus iota sin beta. Now let's expand this. Okay, now what is the real part of complex number? That is cos alpha cos beta, and when iota sin alpha iota sin beta gets multiplied, we have minus sin alpha sin beta, and imaginary part is cos alpha sin beta plus sin alpha cos beta. Okay, so this is mod z1 mod z2. Now what is cos alpha cos beta minus sin alpha sin beta? This is formula for cos alpha plus beta, and this is formula for sin alpha plus beta. Okay, now if I compare this complex number z1 z2 to standard polar form, what is standard polar form? That is z is equal to mod z cos theta plus iota sin theta. अगर हम इन दोनों को कंपेयर करें, ठीक है, then what is मॉड्यूलस ऑफ z1 z2 कॉम्प्लेक्स नंबर? इस कॉम्प्लेक्स नंबर का मॉड्यूलस हो जाएगा mod z1 multiplied by mod z2. And what is argument theta for this complex number? Argument of z1 z2 is equal to alpha plus beta, where alpha is initially argument of z1 and beta is argument of z2. So this is argument of z1 plus argument of z2. So we have these two properties, one for modulus and one for argument. That is, modulus of z1 z2 is equal to mod z1 mod z2. That is, modulus is distributive over product, and when we multiply two complex number, its argument is sum of arguments of given complex numbers. Okay, from this we have mod z1 mod z2 mod z3 is equal to mod z1 z2. If I consider z1 z2 as one complex number, then this is mod z1 z2 multiplied by mod z3. So this is further mod z1 mod z2 multiplied by mod z3. Okay, so in general we have modulus of z1 multiplied by z2 multiplied by z3 up to zn. This is equal to mod z1 mod z2 mod z3 up to mod zn. So if you multiply n complex number, then find its modulus. That is same as you first find modulus of all the complex number and then multiply their modulus. And if I replace all z1 z2 z3 by zn, अगर हम इन सभी को z ले लेते हैं, all complex numbers are z, then we have modulus of z power n is equal to mod z power n. That means you first raise the complex number to the power n, then find modulus. This is same as you first find the modulus of complex number and raise it to power n. Okay, from argument from the property of argument, we have now argument of z1, z2, z3. If I consider this complex number z1, z2 as single complex number, then this is argument of z1, z2 plus argument of z3. Further, this is argument of z1 plus argument of z2 plus argument of z3. So here three complex numbers are multiplied. Its argument is sum of arguments of given complex numbers. Similarly, we have argument of z1, z2 up to zn is equal to sum of arguments of n complex numbers. Like this. And if I replace all complex numbers by z, then we have argument of z power n is equal to n times argument of z. So we have some properties using polar form. When we are multiplying two complex numbers in their polar form. Okay, now let's